Hello everyone, myself Dev Kabra and I am joined by Kirtan Shah and Rudra Goyal. We are here to present our research on cryptanalysis of Hindi language. Cryptanalysis is the process of analyzing information systems in order to understand hidden aspects of the systems. There were many resources which were for the English language and there was no such research which was based on statistical and cryptanalysis of Hindi language. So we calculated several statistical factors for Hindi language such as entropies, frequency analysis, etc. There are some examples of many papers that we have referred for our research. This paper is based on using shift cipher on Hindi language. It illustrates how to implement shift cipher in Hindi, generating random key and performing encryption. And similarly, this paper is based on using affine cipher on Hindi language. So, considering all the previous factors, we made our problem statement to analyze different statistical properties which were for the English language, but in this paper we did for the Hindi language. So, these are the steps that we followed in our research paper. First is the data collection, that is the part in which we found several types of datasets containing Hindi language, such as novels, articles, etc. The second is the data cleaning part, in which we had to clear out some of the discrepancies from the data, such as numbers, English characters, etc. And the third and the final step was to analyze the data statistically using Python language and its libraries such as pandas, matplotlib, seaborn, etc. So using this, we termed out several results such as this is the analysis of frequencies of Vyanjans in which we can observe that the Vyanjan K and R are in the top two orders, and we can see that Anga does not appear in the dataset. Second is the result of analysis of frequencies of swars in which A occurs most of the time after before U, and Ri. And similarly, we can also see the results for the analysis of frequencies of matra, in which a occurs most of the time, whereas a occurs least of the times.
So, hello, myself Kirtan Shah. So, in this slide, here we tried to divide all the Vyanjans into groups based on their frequencies. So, the result can be seen over here in the graph that the first group contains Ka and Ra, then the second group contains Na, Sa, Ha, Ma, and La, and so on. This type of case study makes it very easy to encrypt and decrypt in substitution ciphers. The same can be done for swars, matras also. Then we have done the analysis of diagrams and trigrams by finding the most probable next characters after the letter Ka. This shows the most probable character after Ka. Also after Ha. This also helps in finding the next character in cryptanalysis of substitution ciphers. Then we have found the frequency of diagrams in our dataset. As we can see, K, Ne, and He are the most repeating diagrams in the Hindi languages. This is the analysis of frequencies of diagrams starting with swars. So as you can see, OR has maximum frequency without any doubt. Then this is also derived on the basis of diagrams starting with matras. Now here comes the trigrams starting with vyanjans, and as you can see, May has very high frequency as compared to other trigrams. Then this is the analysis of trigrams starting with swars. Similarly, this is the analysis of trigrams starting with matras. Then we have also analyzed the probabilities of all the possible combinations of vyanjans, matras, and swars, where V stands for vyanjan, M for matras, and same for swars. Here, as you can see, in this bar graph, the probability of VMV is very high as compared to other combinations. We also implemented the concept of word cloud. So as you can see, this picture represents the frequency of the words in terms of their size. So higher frequency of the word implies larger size.
Myself, Rudra Gohil. Studying relationship between different characters of a language is very useful. It can have various applications like cryptanalysis of substitution cipher or natural language processing. The graph shown here is a directed graph in which nodes represent characters and directed edges point towards next character. For example, in this graph, if our current character is gh, then with probability greater than 0.5, we can say that our next character would most likely would be ra. Similarly, these are graphs for probability greater than 0.4, probability greater than 0.3, and probability greater than 0.25. Zipf's law. Zipf's law is an empirical law formulated using mathematical statistics. It states that many physical and social science data follow inverse relation in rank frequency distribution. There is a rank versus frequency graph of words used in Hindi language. From the graph, we can clearly see that they follow inverse relation. The relation can be more clearly visualized in log-log graph. This is the graph of top 20 Hindi words used in our dataset. We can clearly see the inverse relationship here. Word entropy is a property of a language that determines uncertainties in occurrence of different words. We can calculate word entropy using formula where pi is the probability of occurrence of that word and n is the rank of that word. N will be from 1 to critical rank. Critical rank is the probability where occurrence of a word is nearly zero. The average word length of Hindi and Sanskrit are greater compared to English. This is the graph displaying average word length distribution. N-gram entropy is another useful property proposed in which we can calculate uncertainty in occurrence of nth character if previous n minus 1th character are known. It is represented as Fn. Shannon gave this formula to calculate it. In this table, f0 means n-grams of length 0, which means all characters are equiprobable. F0 is greater in Hindi and Sanskrit compared to English because there are more characters in Hindi and Sanskrit. In F1, n-grams of length 1 is considered, which means it is simple probability distribution of all characters. F1 is highest in case of Sanskrit and least in case of English. In F2, n-grams of length 2 means diagrams, and in F3, n-grams of length 3 means diagrams are considered. As value of n increases in n-grams, entropy for Hindi and Sanskrit decreases compared to English. This is because words are more closely related in Hindi and Sanskrit compared to English. In summary, there are more characters in Hindi and Sanskrit, but they are more closely related compared to English. At last, I would like to conclude that in frequency analysis of substitution cipher, Hindi and Sanskrit are more difficult to decrypt as they have more characters, whereas the characters are more closely related and follow patterns in Hindi and Sanskrit, making it more suitable for fields like natural language processing. Thank you.